Okay, now for the next question, number 11 in page 6. It is approximately the same like the previous question. We have three masses, A, B, and C. Each one of them has a mass in grams. Be careful about that. The mass of A is 30 grams. The mass of B is 75 grams. The mass of C is 63 grams. We need to convert them to kilograms just by dividing by 1,000. Okay, and we have mu k and mu s as given. The first one, if A, the first part, if A is in the top of B, we have we need to find the normal force between the table and the bodies. The contacting between them is just for between the table and B. So we have the mass, the weight of B, M multiplied by G. And we have a contacting force between A and B, the weight of A acting on B, and there is a normal subnormal force between A and B. We don't need it. We will take the effective weight from A. It is as a force applied on B, just like that previous question, and this force will be the weight of A, which is MA multiplied by G. Okay, now we need to find the normal force. This is the normal force upward, which is equal to, in magnitude, to the weight of A and B. This is MA, which is 30 over 1,000 in kilograms. This is the acceleration, which is G, and this is the weight of the block B. So the total weight downward will be 1.029, which is equal to the normal force but upward. I will approximate it to 1 newtons. We can do that. So moving at constant velocity, if we need to move these blocks to our system in constant velocity, so the external forces on these boxes should be zero. What are the external forces in our system? We have the friction force for the kinetic state because the bodies are moving, and the applied force. We have applied force acting on these bodies. So we need them to be zero because we don't need acceleration. If the force is zero, the total force is zero, then the acceleration is zero because we have constant velocity. So the friction force plus the applied force must be equal to zero. So the friction force is equal to minus negative in direction to the applied force. But in magnitude they are the same. We know the law how to find the kinetic friction force. It is mu k multiplied by the normal force. Normal force is equal to 1. The mu k is 0.22. It is given. Okay, so the total friction force is 0.22 newtons, which is the same as the applied force needed, but in opposite direction as we told here. Okay, part B. What if A is on the top of C and they are stationary? We need to start the moving. So we need to apply a force to get over the friction force, but the stationary friction force, Fs. Okay, again the weight is the total weight for the two bodies, and the normal force will be equal to the weight but in upper direction, not in down direction. This is the mass of A, which is 30 over 1,000, and the mass of C is 63 over 1,000. They are all multiplied by G. Then the normal force will be equal to 0.91 newtons in upward because the weight is downward. Okay, we need the applied force, this is the applied force, to be the same as the stationary force but in the opposite direction, because always the friction force is in opposite direction of our movement, and the friction force is equal to mu s multiplied by the normal force. Mu s is 0.37 multiplied by the normal force, and that friction the stationary friction force will be equal to 0.34 newtons, which is the force needed but in the opposite direction. Is that clear? Thank you. See you in the last question, which is question number 12.